Welcome to AI GovCast. I'm Ross John Fortunet. The Marine Corps Warfighting Laboratory is tasked with looking toward the future of conflict. The lab studies emerging operating environments, identifies future threats, and develops the concepts and the capabilities that Marines will need to stay ahead. Brigadier General Simon Doran is Commanding General of the Marine Corps Warfighting Laboratory. He joins me now to discuss the ways that the lab is charting the future for the Marines. Welcome to the program.
Good afternoon.
From the lab's vantage point, what insights are emerging and are you seeing about how the Marines can most effectively contribute to distributed maritime sensing and decision advantages in contested environments?
Well, I would say that I think you can see from several of the conflicts that have been going on in the most recent time that we're learning a lot, and that the character of war appears to be changing. And so we're trying to take lessons that we can learn from Ukraine, other conflicts in the Middle East and elsewhere, and see how that applies with being threat informed and concept based for not only what we need to do today, but in the next 5 to 10 to 15 years. Where do we need to make investments, or potentially where do we need to adjust or alter our concepts that will eventually become doctrine to enable us to be, as lethal and as survivable as we possibly can, with our overall mindset being that we plan to be fighting inside the weapons engagement zone wherever we go.
So you mentioned that timeline of 5 to 15 years. Like, what are the prototyping efforts? What kind of experiments are giving you that picture of how these base expeditionary advanced base operations can scale across theaters?
Yeah, the first thing we do is we have to kind of figure out what a common baseline is for what the threat of the future looks like. And so we develop a future operating environment, which, as you know, the further you go from today, the level of uncertainty will grow. But we'll work with our joint partners. We do a lot of modeling and simulation to try and let us know what we think the threat may look like in the next 10 years. From that, we take it into a virtual environment, and then we will take our current concepts, capabilities, and technologies, and we will iterate, thousands, if not hundreds of thousands of times, and do wargaming. And from that, we identify where we may have some gaps or seams in our current concepts, potentially what our force structure is, or more than likely, where we need to make investments in technology that can enable us to be more lethal and survivable in the future. Once we make those initial investments, we will then model and sim once we figure out a high tech research level, the TRL of that particular product, and then we will put it into the hands of Marines and experiment with it before we then propose that as a transition to a program of record. And so the things we're trying to look for today for an EABO for the Marine Corps is that we want to be low signature, we want to be survivable and lethal while we're being distributed in order to increase that survivability.
Tell me about these virtual environments and the war gaming. I'm sure digital twins, stuff like that are involved. How do you create those, and what does it look like, and how does it benefit, the things we're talking about?
Well, we're working towards our initial operating capability in what we call the Neller Center for Wargaming and Analysis. And so we have a 100,000 square foot facility here at Quantico that we're working on all of the software and the IT infrastructure to allow us to take what we would see as a threat in the next decade, create that threat in the virtual environment, and then have a physics-based model to where we can run iterations of our weapon systems against the threat's weapon systems, while simultaneously using our concepts and doctrine and our force structure against the perceived force structure of what that threat would be, all to inform us of where we need to make monetary investments today to increase that lethality and survivability in the next decade.
So to pick on the balance between survivability, mobility, lethality, how are you doing that? How is the lab helping refine that balance as the Marine Corps fields capabilities?
Well, I don't think it's a one or the other. We have to build the survivability into all of it, and it's not necessarily one particular item. Of course, you could imagine that in the spectrum, you need to keep what you're emitting down to a low level. You also have to know what you're emitting in the first place, and so all of that goes into understanding what our formations look like at echelon in order to keep their signature as small as possible. It's not only good enough to have a low signature, we also must be able to carry a big punch. And so trying to increase the effectiveness, the range, and the capability of the fires that exist within that stand-in force are all things that we make investments towards.
Those investments, are they, how are you sort of taking it all in? How do you have people ideate those sort of things, and how does it move, again, sort of move the new capabilities forward?
Well, we start with the direction we're given from our commandant's planning guidance. And so from that, we're investing in things for littoral mobility, logistics in a contested environment. The second priority is to enable joint and coalition kill webs and complete that final portion, that last tactical mile, if you will, for a particular kill web, and then working on long range fires. So those are the three priorities that the Commandant gave us in his planning guidance to make science and technology investments in the form of RDT&E.
Yeah, certainly. I know that kind of stuff was the talk of San Diego a couple weeks ago in at West. I want to sort of pivot to the challenges that, the naval C2 architecture is a priority. What are the challenges that you see at the lab in building that integrated naval C2 architecture?
Well, I think we, as a Marine Corps, view ourselves as being an enabler for the naval force. And by that, I mean we should be able to be in the weapons engagement zone of any threat. We should be able to do sea denial and contribute to sea control from within that weapons engagement zone of a particular threat. Piecing that together from the command and control perspective, we have to be able to do that without perfect information. And by that, I mean either in a degraded or a denied environment where we don't necessarily have access to maybe PLEO or other waveforms. And so building redundancy and resiliency into our ability to communicate, and then also enabling our forces to still execute the mission with less than perfect information.
Hey, man, so my eyebrows go up on the edge computing conversation. That's something I've talked a lot about with Department of Navy folks recently. I know that's a big part of the future, certainly integrated environments.
Yeah, being able to process information at the edge is fundamental to pretty much everything that we do right now.
What's showing the most promise on that note?
Well, for us in the Marine Corps, it's the family of integrated targeting cells. And so those will have different capabilities based upon the echelon that they will be, whether that's at the Marine Expeditionary Force or all the way down to an individual battalion or squadron, and how they have the ability to move information back and forth at the tactical edge and create a node, if you will, at the tactical edge to where we can still find targets, provide that information back to the target engagement authority, and also take the information from the target engagement authority and prosecute those targets at the tactical edge.
There's a lot that goes into all of this. Of course, there's sensing and there's sustainment, all these things. What is most in need of iterative testing and rapid learning that you're working on at the lab?
Well, when you find yourself in an environment where you have complex, multispectral information coming in, and you may not be getting the best of all of it, it's just the ability at the forward edge to sense and make sense of the environment. You have to know what you look like in that electromagnetic spectrum. You also have to know what the threat looks like in that spectrum. And then how can you take advantage of that to have the best possible picture for decision makers to ultimately decide what should be done against the threat and what should the friendly forces be doing in order to remain survivable and lethal inside a weapons engagement zone. We're making a lot of investments in autonomy, manned-unmanned teaming. It's not necessarily getting robots to replace Marines. It's getting robots to enable Marines. We would like to do a little bit more with our littoral mobility. And so if you can imagine units that are inside a weapons engagement zone, we're looking for vessels and vehicles that we would deem risk-worthy, meaning we don't necessarily want to lose them, but we'd rather put them at risk rather than vessels that have Marines on them or sailors in order to resupply or potentially medevac folks. And so looking for collaborative autonomy, mesh networks, and the ability to resupply while we're inside a weapons engagement zone, we view as being something that's quite critical right now. And we're making investments more and more towards the autonomy aspects of that, manned-unmanned teaming, as well as how can we help decision makers with some sort of, enhanced situational awareness by processing the tremendous amount of information that's coming into our tactical units.
Yeah, I imagine the AI side of that is pretty critical to be able to use computers to do things that humans can't, particularly on the imagery side of things. Can you talk about that, what you're doing in that sense?
I can just tell you that we are making investments. Unfortunately, most of that goes out the classification level.
Of course.
But anything we can do to assist in human decision making, but also in just processing the volume of information that comes in. Of certain interest is, of course, cross-domain solutions, so that you can do things machine to machine at machine speed to enable decision making, in the micro or nanoseconds.
Excellent. Yeah. And on the autonomy front, I know there's a lot of unmanned stuff that's going on, but can you talk about what you're doing, sort of bird's eye view at the laboratory to push forward the move towards more autonomy that then thus changes the risk calculation?
Sure, I can give you one example of what we're doing right now for littoral mobility. We have what we call the autonomous low profile vessel. And so this is effectively a boat that is completely autonomous. It can go more than 1,000 miles for resupply. It's very low observable. And I think you can send it and program it to go to a particular point for a resupply. You can also reprogram it en route. We've got 3 of those that we're working with right now to work on the autonomy piece and the survivability, but also figure out how it fits into our formations and what we need to do from a .mil-PF perspective. You know, the training of these is particularly important. We don't want to have to create a new military occupational specialty just in order to figure out how to use this. And so autonomy is assisting us by just taking a few weeks to train a Marine to be able to operate some of these things. And they are risk worthy, meaning that we would put them in a place, where we might not want to send manned vessels for that resupply. And so that's one thing we've been working pretty aggressively on over the course of the past few years. I think a successful effort we have brought to conclusion from the Warfighting Laboratory with our Deputy Commandant for Aviation is our collaborative combat aircraft. It was the XQ-58 Valkyrie. It is now a program of record as the MQ-58, but that's to work manned-unmanned teaming with our 5th generation platform.
That's really moving forward. That's really interesting to hear, and a positive note to end on. Brigadier General Moran, thanks so much for joining me.
Yeah, my pleasure.